Hello, in this video we are going to take a look at calculating probabilities for a discrete probability distribution, as well as look at some common words that are used in probability story problems. Discrete probability distributions describe random variables. A random variable assigns a number to an outcome in the sample space. The probabilities follow two very intuitive rules. First, each probability is a valid probability, so it's a number between 0 and 1, a value between 0% and 100%. Second, the distribution describes all possible probabilities, once and only once, so that the total of the probabilities in the distribution is 100%. The rules that you learned earlier about probability still apply. Let's apply these. So I love summer and going to the carnivals. There is a wheel spinner, and when you spin the wheel, you can earn tickets. You win tickets 5 at a time, and on this spinner, the most you can win is 20 tickets. The probability of winning nothing is pretty high. It's 42%. The probability of winning 5 tickets is 25%. The probability of winning 10 tickets is 17. And I can't really remember what the probability of winning 15 tickets is, but I do remember the probability of winning 20 was only 5%. Can you help me figure out that missing value? What was the probability of winning 15 tickets? Pause the video, see if you can do it yourself. Have you figured it out? Seriously, pause the video and figure it out yourself. Okay, let's move on and see the answer. We have all these facts, and as a big paragraph, it's kind of confusing, but we'll be able to work with the numbers much better if we think of it as a table. Now I can apply that rule of discrete distributions. The total should be 100%. The probability should sum up to 1. There's only one thing missing, so I can use the complement rule. Probability that it was 15 tickets is going to be 1 minus the probability that it's not 15 tickets. Right? 1 minus all these things that are not 15. Get your calculator, add it all up. What do you get? 1 minus 0.89, which is 11%. So there's a 0.11 probability of getting 15 tickets in this particular carnival prize. So knowing that, we can fill it into our table. And now we have the full picture of the probability of winning tickets with this game. Let's ask some more questions about it. What's the probability of winning at least 10 tickets? What's the probability of winning at most 10 tickets? What's the probability of winning more than 10 tickets? And what's the probability of winning less than 10 tickets? All of these questions are really similar. A reoccurring theme in probability is you have to be very detail-oriented. Changing just one word in the question can change the interpretation drastically. So that's what we're seeing here. These words, at least, at most, more than, and less than, will drastically change the interpretation of the question. The first one is probability of winning at least 10 tickets. At least 10. The least you can get is 10. So 10 or more. In mathematical notation, at least would be greater than or equal to. So probability x is greater than or equal to 10 equals. By our union rule, we can add the probabilities. There's no overlap. There's no intersection in these events. They're all disjoint events. So we can just add them up straight out. So 10 would be 17%, plus 15, is 11. And 20 is only 5%. Add them all up, and we get 0.33. There's a 33% chance of winning at least 10 tickets. Okay, taking a look at the next one. What is the probability of winning at most 10 tickets? So that means the biggest number you can get is 10, and anything less than that would also count. Our mathematical relation that expresses at most would be less than or equal to. So probability X is at most 10 would be the probability of 0 plus probability of 5 plus the most you can get is 10, so that has probability of getting 10 tickets. Add them all up, and 0.84. There is an 84% chance you'll get at most 10 tickets. What is the probability of winning more than 10? So 10 wouldn't be good enough. It needs to be more. Okay, our mathematical relation for that would be greater than. So just the carrot facing to the left. I always imagine the carrot is going to eat the bigger thing. So probability X is more than 10 would only be the probability that there's 15 tickets or you win 20 tickets. Lastly, what is the probability of winning less than 10 tickets? That means you didn't even get up to 10. You know that you stopped before you got 10. So less than would be just those two outcomes right there, getting 0 or getting 5. Our mathematical relation, less than. Probability X is less than, but doesn't get all the way up to 10, less than 10, would be the probability of getting none or the probability of getting 5. There's a 64% chance you would win less than 10 tickets. I hope this video has helped you become more comfortable working with discrete probabilities and reminded you it's very important to read carefully when answering probability questions. Happy studies!